LearnCity. My name is Praise, and in today's class we'll be solving examples on alternate segments and tangents to a circle and circle geometry in general. Now, first example is in the figure below. PT is a tangent to a circle ABC, ABCT, where our BA is equals to BT and ATP is 82 degrees. We then calculate BCT. We have our ATP to be equals to 82 degrees. Now, we can basically see the diagram where we have our ABC, we have our triangle inscribed in our circle from our tangent CP, where we have angle 82 degrees around A, C, and P. We have it to be 82 degrees. Then we have to look for our B, C, and T. Now, to solve for that, to know that our APT is 82 degrees. As our ATP is 82 degrees, then also our ABT will also be 82 degrees in which alternate segments. They are alternate segments. Now, for our BAT, we have it to be 180 minus 82 degrees, which is sum of angles in an isosceles triangle. So for our BAT, we have it to be 180 degrees minus 82 degrees, which is the sum of angles in an isosceles triangle. So 180 minus 82 degrees, we then have it to be 49 degrees. So now to find our BTP, our BTP will now be our 82 degrees plus 49 degrees. Where this gives us 131 degrees. So we have our BTP to be 131 degrees. Now, our BTP, which is 131 degrees, is now equal to our BCT. So our BTP is equals to BCT, where it is alternate segments. So this example has basically explained to us how alternate segments are in with each other. Now, our second example is calculate the size of theta in the figure below, where O is the center of the circle. We have our first diagram to be this circle, where we have A, we have T. We can also see it we have O, here is P, we have B, and we have theta. So here we need to understand that our ATP is 90 degrees. This is our T. Our AT and P is 90 degrees, which is radius of a tangent. We have our ATP to be 90 degrees, which is the radius of the tangent. Now, our BP and O will now be 20 degrees, which is the base angles of an isosceles triangle. So to find our theta, we now have it to be 180 minus 20 plus 90. So we have it to be theta will now be equals to 180 minus 20 plus 90. We have it to be 180 minus 110 degrees, we have it to be 70 degrees. So our theta here is 70 degrees. So our theta here will be 70 degrees. Now, for the second example, we have a circle where we have a point O. We have here to be theta. We have here to be 62 degrees. We have our line P, T, and B. So here we already have our angle, which is 62 degrees, and we have our theta. So the first thing is that it is important to know that our ATO is 90 degrees. Our ATO is 90 degrees, which is the radius to the tangent. So our PTO will now be 90 minus 62, which is 28 degrees. We have it to be 28 degrees. Then our OPT is now 28 degrees, which is the base angle of the isosceles triangle. This is the base angle of the isosceles triangle. So to find our theta, it will now be, then it's important to know that our PTO is 28 degrees, then our OPT is also 28 degrees. So we now have it to be our theta will now be 180 degrees minus 28 degrees plus 28 degrees. So we have it to be 180 degrees minus 56 degrees, where we have it to be 124 degrees. We have it to be 124 degrees. Now, the final example, we have it to be O is the center of a circle, and two tangents from a point T touch the circle A and B. BT is produced to C, and where AOT is 67 degrees, calculate ATC. We have to find ATC. So we can see this diagram where we have our tangent T from point O from chord A and B, where it's touching at point A and B. So our line TB extends further to C. So for our AOT, we have our AOT to be 67 degrees. Now, for our ATC from that point BT, which extends to C, then our ATC will now be what? So, what is the first thing that we are going to do? We have our OAT to be 90 degrees. Our OAT is 90 degrees. Then our OBT is also 90 degrees, which is the radius to the tangent, which are equal. So we have BOT. We have BOT is 67. BOT is 67 degrees as given in the diagram. So to find BTO will now be 180 minus 80 plus 67. Okay, 90 degrees, sorry. 90 degrees plus 67 degrees. So we have this to be 180 degrees minus 157 degrees, where this gives us 23 degrees. Now, similarly, we have ATO to be 23 degrees, which are symmetry lines, because they have BTO to be 23 degrees, and definitely ATO will also be 23 degrees at the angle at T. So now for our ATC, to now find our ATC will now be 2 times 23, since the line extends from BT towards C. The line extends to point C. It will now be the exterior point. So it will now be 2 times 23 degrees, where we have it 46 degrees. Since the line for BT extends to point C, which is the exterior part, towards the exterior part, so we have it to be 2 times 23 degrees for us getting our 46 degrees. And this brings us to the end of our class on circle geometry, where we've talked about the tangent to a circle, we've talked about alternate segment, we've talked about tangents from an external point, we've talked about tangent to circle, we've talked about chords, and this brings us to the end of our class on circle geometry. Do subscribe to our YouTube channel, like and comment, and I'll be seeing you in our next class. Thank you.